Hey, good morning, good afternoon, good evening, wherever you are. Welcome to the stream today. I'm Danielle, the host here, and today we have Mohammed Izzy. He works for a company you may have heard of called Serverless Guru, and he's also an AWS community builder. We're really excited to have him here to chat with us about Apache Flink and serverless event-driven apps with AWS. So let's bring him up.
Hello, everyone. Hey, Daniel. Thank you so much.
Yeah, we're really excited to have you here. Yeah, for the folks in chat, feel free to ask your questions as the presentation's going on, but we're going to wait until the end to answer them. So definitely appreciate your engagement here. Let's get your screen up.
Okay, so let me just share my screen. 1 second. Let's see. Okay.
Let me unmute myself. Cool. Let's get you up here. And
all right.
Cool.
Great. Hello, everyone. Before I start the session, just to give you a quick background about myself. I've been working with Serverless Guru for about 4.5 years. I've had the opportunity to work with some amazing members of my team. And during the course of these 4.5 years, I've had the opportunity to work with data streaming, specifically CEP. And I had quite a bit of understanding on how things would work when we try and incorporate a CEP layer within serverless event-driven applications. And with that thought, let's start the session. So before I get into the meat of it, I just want to go over what we are going to be talking about as part of the session. So the first thing is what CEP and what exactly Apache Flink can do. We'll try and look at some basic in terms of the framework and how to get started on AWS. And finally, we'll take a quick look at a very simple application to understand how it sort of works. So Flink is actually one of the CEP frameworks. CEP stands for Complex Event Processing, and it is just a set of techniques to aggregate events at scale based on certain business rules that you define, and we derive insights from it in real time. So if you have any event streaming use cases, Flink is actually a very strong framework to consider. We do have other frameworks too. I think we have Kafka streams. We've got Spark as well. There are multiple frameworks out there, and each of them have their own sort of use cases. But Flink is probably one of the most popular ones that I have actually have experience with. So what exactly can Flink do? As I said, with CEP, you can detect patterns and identify anomalies at scale. Well, one of the key features that I think with Flink is stateful processing, because as we know in the serverless ecosystem with Lambdas, they are stateless. But having this stateful layer within your event-driven applications, it can really make a huge difference. And Flink can do that really well. The other use case is that, let's say if you want to correlate from multiple event sources, when you have multiple streams of data and you want to derive some insights out of that data, Flink can do that too. So let's say, for instance, you have an order processing system, and you have, I don't know, maybe you have an order stream, and then you have a payment stream, and you want to combine these two independent streams together to get some insights. Flink is capable of doing that too. Another powerful feature is windowing. So think of windowing as slotting your events into buckets and then processing them based on time. So you have different kinds of windows. Again, it's an advanced concept, but it's good to know that Flink is capable of doing things like this too. There are so many use cases that you can work with. It all depends on what you're looking to do at the end of the day. Some of the popular use cases I can think of is if you want to do real-time analytics, you want to do fraud detection, you want to do some sort of a recommendation system and log analysis. You can also do clickstream analytics. So, I mean, the possibilities are endless. It's all about just deciding on what exactly do you want to do with it. Before I get into explaining how Flink works and how we get started on AWS, I just want to quickly touch base on Kafka. I'm sure that most of you already know what Kafka is, but for those who don't, it's think of Kafka as your messaging broker. If you have a distributed system and you're looking to process streams of records, Kafka is a very good message broker to pass on messages between between your services within your system. How it works is a Kafka cluster can have a number of topics, and each topic can have multiple partitions. So think of topics as folders where you have the same set of data within each of these folders. So every record stream that you want to operate with can be an independent topic. And then multiple consumers can subscribe to a specific topic. And then each of these consumers can process data at their own pace from that topic. Partitions within these topics are like, think of them as the number of lanes on a highway. The more lanes you have, the more vehicles you can accommodate, and the better would be the flow of traffic. So you want to decide on the number of partitions depending on the throughput of your event streams, and also it's going to define how the overall performance of your system is going to be. The other thing is ordering can be quite important in quite a few scenarios, and how we achieve ordering within Kafka is by ensuring that from a producer standpoint, when you're pushing events into a topic, you use a common key. The key has to be from the event itself and can be anything which is unique. Now, going back to the same example of a customer auto processing system, let's say the customer ID is unique. So when you push in events to that topic using the same customer ID, Kafka is going to ensure that all these events belonging to the same key go into the same partition within that topic. So when the consumers are consuming from that topic, it's always being consumed in the very same order as they arrive from the source. With that, let's get into some basic concepts of Flink. Again, it's a lot. So what I'm going to do is I'm going to touch on some high-level things that we should know, at least enough to get started on with. So the first thing that I want to talk about is operators. Operators within Flink are just internal functions that can be chained together one after the other. So the output of one operator can be an input of the other when you chain them together. And these operators they are part of the framework itself. All you have to do is just extend them and you define your business logic within these operators. There are different types of operators and each of them have a specific sort of use. It all depends on what you're looking to do at the end of the day. When you work on CEP frameworks, you can define the kind of streams that you want to work with. So within Flink, you can have keyed and non-keyed. As the name suggests, a non-keyed stream it comes directly from the source. You subject it to an operator of your choice containing a business logic where you process it, and it goes out to your sink. Sink is nothing but the final destination. That is where you want to push your processed payloads after Flink has done processing with it. A sink can actually be anything. It can be another Kafka topic itself. It can also be a Kinesis data stream. And the various connectors available, it all depends on your use case. Keyed streams, on the other hand, is what you would do when you want to enable stateful processing. So sort of similar concept when it comes to ordering with Kafka, where you define a key, you would also define a key in this case. So key by is the operator within Flink. And what you would do is um, with an order processing stream, let's say you choose customer ID as your key. Now, what would happen is internally within Flink, when events come in belonging to a specific key, they would go within the very same partition inside of Flink. And that would actually enable sharing of state within those events. So a state is nothing but it's a set of variables that you can define. It can be of any type, Boolean or value type. It can be an array or a list, whatever you want. Any data that you want to share between these events as they come in so that they can be used as part of your business logic. The other powerful feature that Flink has is with timers. Timers, as again the name suggests, is you can execute certain pieces of code at specific periods of time. Imagine that you have a use case wherein you would want to collect events belonging to a certain key, and maybe you don't want to process them immediately, but you want to wait for 5 minutes and then process all of them together. This would also, it would a better way of doing this would also be to use windowing, a tumbling window. But again, like I said, it's the different ways of accomplishing a given task. And timers is like the starting point when you want to work with processing events based on buckets of time. And again, timers are available only within certain operators within Flink. It's not with all the operators that you have. And it's only for keyed streams and not for non-keyed streams. One of the final aspects of Flink, which is also crucial to performance, is parallelism. Think of parallelism as the number of tasks that you can allocate. So if you have a higher parallelism value, you allocate that many tasks, and it all depends on the throughput of your data stream, your input stream. So if you have a very high throughput stream, you want to make sure that you allocate an optimal parallelism value so that it can process these events in real time, and then you don't have performance bottlenecks. This also sort of relates to partitioning within Kafka, which is why I brought it up previously, because when you defined partitions of a topic, when Flink happens to be a consumer of that topic, it also detects the number of events that can flow in. So you want to manage both these aspects. A parallelism value cannot be higher, or rather it shouldn't be higher than the partition count, because if you have, let's say if your partition count is 4 and you set a parallelism of 8, you are only consuming from 4 partitions, and it's quite possible that the other 4 tasks within your Flink layer are actually idle and just paying for compute when there's no use at all. So you'll have to fine-tune them with some performance tests to understand your actual requirement and set an optimal value. It can be set, so the parallelism again can be defined at the operator level itself. So when you have, let's say you have 5 operators or rather 5 functions, you can choose that, okay, because you have some complicated logic between one of these 5 operators, you can allocate a parallelism value accordingly for that specific operator. Although it is recommended that you do it at the environment level so that the operators are not skewed in terms of the tasks that are allocated for it. And I know it seems a lot of information to process in the span of a few minutes, but just to help you understand things a little better. So I'm just going to talk about, again, the order processing use case. So you have your event stream, which is coming in. Kafka is your message broker, which is helping you pass messages between your systems, and Flink is the consumer to one of these topics that you have created. So when those events come in, What we're looking to achieve as part of this sample scenario is I want to send out events from Flink and do something in downstream when the customers order two specific products on a specific on a given day. Okay, so I know what those product IDs are, and if they have placed within the same order or they have placed in maybe in different orders, I just want to make sure that I detect it, and then I pass it on to my sync, which is again my Kafka topic, and then maybe send some sort of a promotional email or something, anything. So how do we go about doing that? Because this would require stateful information. I would want to know that, okay, if a given customer has already placed the order for the first ID that I'm looking for, I just have to wait and watch out for the next one, which requires having prior knowledge, and that is stateful processing. So what I would do is I would key all my incoming events with a customer ID. So customer ID is, if you see, we have 4 of them. And what would happen is all events belonging to the same ID would actually go into the same partition as I explained previously, and it will allow you to share that state. So what I've done is I've created a variable of type number with which is going to hold my product ID. If I detect that a given payload contains this value, I just want to add it to my state and then wait to see if the customer has placed the order for the next ID as well. And only if it does, that is when I actually want to do my processing. That is where my business logic kicks in. And the operator that I've employed for doing this is a process function. You have the operators have different names. They are called flat maps. They call process functions. You have window operators. You have even keyby is actually considered an operator. So you chain them one after the other, and then as they're chained in, so the output of one is an input to the other, and then finally you just push it out to your sync. Okay, so let's talk about maybe what I'll do next is I will just show you the application itself and how it sort of works internally. But before I get to that, I also want to talk about how easy it is for you to set it up on AWS. So they have a managed service, which was earlier it used to be under Kinesis Data Analytics, but now they call it MSF, Managed Service for Apache Flink, I think, if I'm not wrong. And what it does is it takes away all the heavy lifting for you. So you just focus on building the application itself, and the underlying dependencies and whatever it needs to spin up a Flink job is all being managed by AWS, which I think is great if you're starting off, because spinning up your own cluster can be time consuming and it's a little complex as well. You can do the same thing through an EMR cluster as well, but that requires a bit more understanding of how all of the pieces fit together. And that is ideal when you want to have more granular control over the configuration. Because with the AWS offering, you're sort of restricted in certain ways, but that's okay because they have always chosen what is best as defaults, and so that you can focus on just building out your your business layer. And all you have to do is just drop your file. So we'll get to that. You just drop it into an S3 bucket, and that is where you would host all your code in there. As I mentioned, so your source and the sink for a Flink instance can be anything. You can work with Kinesis data streams as well. You can use Kafka topics, which is, I would say, probably the best one. But then if you do have use cases wherein you want to process from a Kafka topic, but then you want to insert into a DynamoDB table, you can do that directly from Flink, as opposed to pushing to a Kafka topic, having a Lambda consumer to that topic, and then doing the updates into the DynamoDB. Or if you want to write directly to an S3 bucket, that also is possible. So they have connectors for all of this, and yeah, it's quite good. So let me just go in and share screen. Just one moment. Let's see. think, yeah, it should be visible. So what you see in front of you right now is like the entry point of your application. This is your job file, and this is where you would define, the application settings, the operators that you want to use, and all of that in here. So this is like the entry point of the whole thing. You can of course have the whole logic and everything placed in one file, but I wouldn't suggest doing that. It's better to have different folders and sort of compartmentalize for better management. So what we have here is it's all boilerplate. You don't have to do much in here. Because it's deployed on AWS, it also gives you access to certain properties that you can use during runtime, and use them as part of your business layer. So what we're doing here essentially is we're just getting that the bootstrap servers, which allow you to connect to the Kafka topics, the topic name itself, which is for your source and your sink, and use that in when you specify your connectors. So Kafka source is the connector that we use to work with Kafka, and sink is, as the name suggests, is for your output. So yeah, again, it's all sort of boilerplate, and this is where you would start with your streams. So you get from your event source, and you would have all the operators chained one after the other. So if you see, we have two in here, but one is key by and one is your process function. So key by is where I'm saying that, okay, for every event that is coming through, which is a JSON payload, I want to extract the customer ID. I want to key it with that ID. And then finally, I want to make sure that all of these keyed events go into my process function. You map the sink, that is after your process function has done its work. Where do you want to push those events? So you define your sink as well, and it just goes in. And that is pretty much it, at least from this job file. You'll see a bunch of other files as well on your left. So you can define your tests within the test folder. One thing that I want to mention, so if you notice, we have something called set deserializer. So deserialization and serialization happens at the entry and the exit points of Flink. And you can, of course, choose the defaults one, or you can define your own. There was no real need for me to define my own in here, but I did so anyway, just to show you that it is possible. Because let's say the events arriving from the source have been encoded or have been compressed. And of course, Flink doesn't understand any of that, right? You have to transform them so that it finally becomes a JSON payload, which this key by operator can work with. So over here, when it comes into this piece, we have to make sure that it's a JSON payload. Only then this thing is going to work. So how do you go about doing it? Is you just extend from the deserialization class, and you define what you want to do as part of this function in here. So what I've done is it's just base64 encoded. So all events coming into Flink from the source are base64 encoded. I just decode it, and that is it. That's all I'm doing in here. But of course, you can do other things as well if you have to decompress. If you see this commented out bit talks about how you would do it. And then when it comes to serialization, that is when you push your events from Flink, you can also define the key that you want to do. So ordering, right? I was talking about when you push events to a Kafka topic and you want to maintain ordering, you would want to make sure that you define a key. So that is what I'm doing here as well. I want to make sure that when my events go into the derived topic or the sink, they're ordered so the consumers can process them in the very same way that Flink pushed. So that is what I'm doing as part of the serializer in here. And you have to define them as part of your connector. So within your Kafka source is where you set your deserializer, and your serializer goes in here. There are other settings as well. If you see, you can also define things like partition discovery. So imagine that you started off with 2 partitions from your source topic. but then you realized, oh, okay, I have to increase it now because my throughput is a little higher, and you want to make sure that Flink is actually consuming from that new partition as well. You can define the settings so that it's always looking for any new partitions that might have been created. Likewise, on the sync side as well, sometimes if you're unable to push events to a topic, you can define things like transaction timeouts so that it's not stuck in a loop. And all of this is done sort of internally, so you can override these settings. And yeah, that is pretty much it on a high level. Oh, okay, I think I missed to go into the main code base. Okay, so this is your process function. So the last bit after you create your streams, you get into your process function. And with all operators, it's all about just extending the classes that has been defined as part of the framework, and you just put in your business logic within these functions that you override. Now, because it's a keyed stream, I have to extend the keyed process function. I'm defining two variables that I would want to use as part of my state. So all events belonging to a given key will have access to this variable when I instantiate and assign a value to it. And so this is the core piece. As I mentioned, I'm looking for two specific product IDs, and only once I've found them, I want Flink to go and push that payload into my sink, and then the downstream system can do what it needs to, maybe send some sort of a promotional email or anything of that sort. And that is essentially that we want to do overall. I also have a timer placed in here just to show that how timers work. So what I'm doing is, once I've detected that, okay, when I've received at least one product ID, I want to wait till I clear this state, because I only want to do it for 24 hours. I don't want to keep looking for these product IDs indefinitely. So when I reach the end of day, I'm just going to clear the whole thing, and then on the next day I do the same process. For again, all of this is done at the key level, which is specific to that user only. So only when that user has ordered these two products on the same day, it's only then that Flink is going to go and push it to the sink. So as a cleanup activity, I've used the timer to go and just clear my state, and it's just going to reset the whole thing. So though this is not the best use of the timer, because the timer can also be used for kicking off certain pieces of your code at specific at specific moments of time. You can also do your cleanup activity of state using the state TTL library, which is again part of Flink. But this is just to show you an example of how it would work. And then finally, when you've decided that, okay, I want to collect this event, I want to push it to my sink, that is where you would do something like this, which is out.collect. Yeah, this is a very basic application on a high level to explain how it works. And working with keyed streams, yeah, this is, you would probably be using the process function, I would say, most of the times when you want to work with key data streams involving state. Because the thing is that the timer function itself is available only part of this process function, and not within other operators of Flink, which is why I said that this will probably be your choice when you want to work with key data streams. And yeah, so I have written like some basic tests in here. You can automate the whole thing. So with tests, again, there are two types of tests where you can just emulate. It's again just extending all the capabilities of the framework itself. They also have the test classes that you can extend and write your code accordingly. So you're processing specific pieces of your logic before actually deploying to the cloud. Because sometimes what happens is troubleshooting certain issues on the cloud after you've deployed can be quite difficult, because the logs themselves are quite verbose, and it's not very direct in understanding what's going wrong. So what I do usually is I would first write up the whole thing, even do my end-to-end test to make sure that the logic actually works, and then I go ahead and deploy. That is it. Now let's go and quickly take a look at how things go about when you want to deploy this jar file onto your AWS account. Let's see. Okay, all right. So I already have set things up, in the interest of time, because spinning up a new application takes about 5 minutes to start up. So as I was saying, it's quite simple actually. If you want to kick things off, I can even show you how it works. You just go, you can do it from scratch. You can define which framework version you want to use. You ideally want to pick the latest one always.
Sorry to interrupt. Are you trying to share your screen?
Oh, yes, I am. It's not visible?
Let's get that up there. Yeah, I'm not seeing it.
Oh, no. Okay.
Should be like an AWS console window, I'm guessing.
Yep, yeah.
Cool.
Oh, no. Okay.
Yeah, let's get that up there.
How about now? Do you see it now?
Yeah, cool. I'll leave it to
Okay.
I'll leave you to it.
All right. Okay. So let's go again. Okay. So this is the MSF dashboard where you can manage all your apps. And when you click on create a new one, it's quite straightforward. So as I was saying, you want to pick the latest version of the framework. Just give a random name, maybe just call it test BIS. The role is automatic. And the thing that I noticed is they have introduced quite a few features which were not present previously. So one thing is automatic rollback. Imagine that you've deployed a new version of your application and for some reason it's failing. And what happens is, if your application was running successfully before the deployment, it would just go back and resume from there, which is actually a good thing to have. Because ideally what we would do is we would just stop the whole thing, go back, and you have snapshots that you can take. And snapshots are important when you're working with state, because it's a temporary cache, right? So when you want to resume processing from that previous state, you have a snapshot that this will take for you automatically, and you can just resume from there. But this is a good feature to have. And then you have the other settings, which has got to do with parallelism and all of that. We'll get to that in a bit. But for now, just you select development, which is you only start with a value of 1, and you hit create. So it's just going to create an app, and then you have to point it to that S3 bucket, which you will define in the next screen. So once you hit configure, this is where you can provide the location of your S3 bucket where your built jar file is present, the package jar file. And you can also choose if you want to enable or disable snapshots. The other configuration that is got to do with checkpointing, and if you want to enable automatic scaling. So checkpoint is something I didn't talk about, but it's got to do with maintaining or keeping track of the internal state of your application. So as you keep getting events and as you keep creating state per key, it's going to accumulate data within your internal cache. Right? So checkpointing is one way to keep track of the state that you have, because if in case there's a failure, how does Flink know that, okay, I have to resume from this point? So it would go back to the previous successful checkpoint, so you don't lose all that information, all that state, and it just resume from there. So checkpointing is that on a high level. And parallelism, as I said, defines how much of how many KPUs. So KPUs is Kinesis processing units, and I think one KPU is about 50 GB of storage. It's one vCPU and 4 GB of RAM. So depending on how much compute you need, based on your throughput, you would define an optimal value for that. So usually you want to start off with 1, and see how things are going. Because if you have automatic scaling enabled, it's going to scale on its own anyway. The thing is, you want to set the optimal value right from the get-go, because scaling requires about 5 to 10 minutes. And maybe if you have time-sensitive applications, you don't want to pause your processing for those 5 or 10 minutes. So it's better to always set your ideal parallelism value from the start. And you only get to know that once you do performance tests. It requires a bit of fine-tuning and monitoring your applications. And this got to do with logging. You can define different log levels, and the last bit is about networking. So when you have an MSK cluster, which I already have set up, you can directly just choose the VPC of that cluster. It'll show up in here, and that way you're able to directly connect with an existing MSK cluster if you have defined it. You can also define custom VPC configuration if you have a different setup. Anything works. And that's it. Once you hit save changes, and if I had given the bucket path, it's going to start my application, which is, it's going to look something like this once you have it up and running and you click on your dashboard. So this is your dashboard view. It's going to give you an insight with all the operators that you have defined within your Flink application, the parallelism value, how much of data have you passed between one operator to the next. So for now it's all 0 because I just restarted the application. And any exceptions that you have is going to show up in here. The configuration that you have sent on the parallelism value and all that is going to show up in here. Again, all of this is something that you will have to explore to get a better understanding. I feel I don't want to overload with too much information for now. But I think this is a good starting point if you're looking to explore Flink. Yeah, with that, let me go back to my slide deck. Okay, so in closing, there are a few points that I want to talk about. So if you're looking to deal with streams of data, then maybe using a CEP framework is a better choice over a Lambda function, because I know that whatever we've seen so far, if I want stateful processing, I can definitely do that with Lambda and a DynamoDB table. What's stopping me from doing that? But then it's also about cost and performance, right? If you have extremely high throughputs with multiple data streams, then maybe CEP is a better choice over a Lambda function. And the things you can do, so Flink is also capable of making API calls if you want to get, if your business logic requires getting some information for enrichment, or it can be anything. You want to avoid doing that, even though Flink is capable of doing it, because the processing with synchronous processing, the performance might take a hit if you start making API calls within your Flink layer. So just sticking to pattern detection and whatever you have with the event, and sticking to the context of the event itself is better off than doing anything else apart from that. Even when it comes to payload transformations, you probably want to hand it off to your consumer Lambda of that derived topic. That is your sink. And talking about partition count, this is the same thing that I was mentioning previously. Defining an optimal partition count is going to have an impact on your performance as well. So you might have to, again, fine-tune, look at the metrics, and understand what's happening. Also, you can have partition counts defined appropriately when your consumers happen to be Lambda functions, because the number of concurrent Lambdas that you will have depends on the partition count of a topic. So even though you have a high volume of events, but if you've set the partition count to only 5, then you're not going to have more than 5 or 6 concurrent invocations from lambdas. So the best way, usually not just for Kafka topics too, usually you want to try and batch your events, so to make sure that there's no heavy lag when you're working with high throughput streams. And the last bit, not specific to Flink or CEP, but in general, you want to try and leverage as much as you can at the infrastructure level, which is using event-bridge pipes. I think it's a great fit, especially when trying to build your event-driven systems. With Kafka being your source, if you have any enrichment or you have any filtering requirements, you can have that in as part of your pipes. And then the final destination can be an API gateway, or it can be an AppSync API, depending on whatever you're looking to do. So try and leverage as much as you can at the infra level itself. And with Flink just being your component for pattern detection when working with data streams. And yeah, that is pretty much it. Thanks so much for tuning in. I also have a link to that repository, the sample app that we've seen. If there are any questions, comments, or anything, let's take a look.
Cool. Thanks so much, Mohammed. This was great. Yeah, it looks like we did have some questions. I can pull your screen down here.
Sure.
Looks like Abraham said if you had the PowerPoint presentation, if you could share that.
Yeah, absolutely. Sure, I'll do that.
Cool. We had a question from Samuel. How do you unit test Flink? Focus is just on the operator function and the mock state around
it? Yes. And you don't have to mock state. You can actually do the whole thing. So let's see. So the unit test, yeah, it sort of it uses a JUnit in the background, and you can actually extend parts of the framework to write your unit test around those specific operators that you have. So maybe if you take a look at, I don't know if, let me see if I can share quickly. 1 second. Okay, so in the IDE, if you see, I have actually 2 types of tests. The first one is just focused on the operators itself. What I'm doing is I'm actually going through right from the deserialization all the way to my process function operator. And all of that is actually being done by extending the classes within the testing library itself. So you have all of these test libraries, and you can define whatever comes out of these operators is where you would validate your inputs and outputs against. Okay, if I received these many events, then I consider that, okay, things have worked as expected with the state. And the thing is that there can be certain limitations when you're working with writing these tests. Like, for instance, you can't really test your timer logic. At least in this current setup that I have. I'm sure there might be, if we really try, there has to be some sort of a workaround, but in this specific setup, we are unable to do that. And if you really want to emulate the whole thing, you can do it with this. So what I've done is I've marked the whole, the source and the sync setup itself, and how it would look like when the events have come into Flink, and when finally it's being processed from Flink. So yeah, I was just taking a look at the GitHub repository, and maybe if you have follow-up questions, we can we can chat on that.
Cool. Yeah, great question. I think we have a few more here.
Very important question, I'd say, because testing is definitely a thing on Flink. when you deploy your application, it's quite difficult to troubleshoot if you don't know what's happening.
Yeah, for sure. Samuel also asked, does MSF autoscale the instances and or parallelism within the app?
Yes, it does. So when you check that box of autoscaling, if Flink detects that, okay, so as per the documentation from what I've seen, is whenever the CPU utilization is above 75% consistently for 15 minutes, it's going to automatically scale the parallelism value. So it does that for you. And it's during that auto-scaling phase where your application might be, I think it does continue to operate, but not at full capacity because it's doing something in the background, right? But yes, it does that.
Cool. Yeah, looks like we had a few more here. Let's see if I can find. Yeah, there was also some discussion. It wasn't like directly asked, but some discussion about like if you use Flink, is it Java exclusively, or can you use other languages?
So you do have support for Python as well, but I think there are limitations in terms of what APIs you can use with Python. I think it's only the table API, if I'm not wrong. We'll have to take a look, to be honest. I don't want to say something which is incorrect, but I do know there's Python support. But primarily, I think Java is like the base for Flink. And then we do have support for Scala as well.
Very cool. And then let's see. This might have been asked during your demo. Yeah, I see there's no need to assign an IAM role. Is it because Flink is designed to run offline and not access AWS services?
Oh, no, there is. Maybe I went through it a little too fast when I was walking you through the setup. But then there is a setting in there where you have to provide an IAM role because it needs to push logs to CloudWatch. It needs access to that S3 bucket as well, right? To pull the jar file. So yeah, it does need all of that, even in terms of networking, to sort of have those network interfaces set up when you place it within a VPC and all of that. Yeah, it does need, even from a security group standpoint, because it has to connect to your Kafka instance, right? The topic as well. So yeah, there's a definite requirement for IAM role as well. It's just that when you do it, so again, I forgot to mention, please do not do ClickOps. You always want to use IAC. So anything that you provision, always do it through an IAC framework of your choice. It was just to show you how things work, but yeah, ClickOps is definitely the way to go.
Yeah, definitely. Awesome. Yeah, I think that's it. Yeah, lots of folks saying thanks for the great session. And
thanks a lot for having me.
Yeah, totally. And I guess my last question for you is, if folks have follow-up questions or like want to keep in touch with you, what's the best way for them to get in contact?
LinkedIn, Twitter, yeah, anything works. Email as well. I think, did I provide my email in the last slide? If not, okay, let me just quickly share my screen. Maybe
yeah, totally. Yeah, and he's also in the Believe in Serverless Discord as well, too.
Yeah,
so if you're in there.
So that's my Twitter handle. And this is the link to the repository as well. Please do reach out if you have questions or if you just want to have a quick chat. I'm up for everything.
Awesome. Yeah, let me take a quick look here. Looks like we have a few more events coming up next week. October 17th, we've got an introduction to Amazon Q for the discerning developer. And then also later this month, we've got October 22nd, a story about outages. So kind of along the lines of like scary Halloween October month type of thing. So definitely tune in for that. If you're not a member of our Discord, I believe it's believeinserverless.com, and then there's a Discord invite. Everyone's welcome, regardless of, ability level, or if you're just serverless curious, everyone's definitely welcome. We've got some great conversations. Mohammed's in there as well. And yeah, I think that's all I had. So thank you so much for joining today. Thanks for the talk, Mohammed, and thanks to the chat for the good questions. See you all later.
Thank you. Bye-bye.